Hi everybody and welcome to our review for section 6.3. Alright, let's get started. Alright, so the first slide here is about the multiplication principle, right? So it's the idea that if you have a given number of tasks, so in our case here we have M tasks, right? So T1 is for the first one, T2 is the second task, T3 is the third task, Tm is the M task, right? And so on and so forth. And if you know that you can perform the first task in N1 ways, the second task in N2 ways, and keep going that way until you get to the Mth task, and that can be performed in NM ways, right? And all these N1, N2, all the way through NM are just numbers, right? Positive numbers of ways to do these tasks. And the idea is if you're asked to find the number of ways of performing the task at T1, T2, all the way to Tm, all you have to do is you have to multiply the numbers N1, N2, all the way through Nm together. So you have to multiply the number of ways to perform these tasks to get the number of ways to perform all the tasks. Right, so just multiply those numbers, and answering the questions in 6.3 really just boils down to you figuring out what are the tasks, what are the number of ways to perform these tasks, and then multiplying these two numbers. If you can figure that out, that's really every question in 6.3. So let's do a few examples that are relevant to what you might see on the quiz. So let's go to the next slide. So this is like number 10 on WebAssign. We have to answer 4 questions here. On WebAssign, we have to answer 2 questions. So I just added a couple more questions just to cover more material. So let's get started. So this question, we're trying to figure out how many passwords are possible, right? So these passwords have 5 characters, and we're told that we can choose from lowercase letters of the alphabet and the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so for all the problems, we have to figure what are the tasks and in how many ways can these tasks be performed, right? So all the problems are asking us about passwords, so the tasks are going to be the same, right? So tasks here are just the characters used in making these passwords, right? So characters, there are 5 of them, so we'll say T1, T2, T3, T4, T5, right? So if you had 10 characters for your password, you'd have T1, T2, T3, all the way through T10, right? So our M here is 5. We have M tasks, 5 tasks. All right, so those are the tasks. Now, the number of ways to perform these tasks depends on what the question is asking you. Is the question telling you you can only use numbers? Or maybe you can only use lowercase letters, or you can use a combination of them, right? So the idea is you have options here. It just depends on the question. So for now, for number of ways, we'll just say our options are to choose from the 26 lowercase letters from the English alphabet. So LC for lowercase letters. And then another option is to use the 10 numbers, 10 digits, 0 through 9, including 0 and 9, right? So those numbers. Okay, so let's look at number 1. So number 1 says, how many passwords are possible if only numbers are used? Well, we note that there are 10 numbers, right? So a way that I like to do this is how Brian also does it in his completed notes in 6.3. is he writes down T1, so we write down all the tasks, T2, T3, T4, T5, right? Keep going this way for however many characters you have, right, for your question. And then that's equal to. And then above the line there, we're going to write down the number of ways these tasks can be performed, right? So those would be like the N1, N2, N3, N4, N5 in the previous slide. All right, so the idea is we can use only numbers, but we're not told that we can't repeat numbers. We're not told anything like that. So you could have a password that's just 0, 0, 0, 0, 0, 1, 2, 3, 4, it doesn't matter. You're allowed to repeat numbers or not repeats. You can choose whatever you like. So the idea is the number of ways to choose these characters, the number of ways to perform these tasks are 10 for each character, right? So 10, 10, 10 here, 10 here, 10 here, which is 10 to the 5th, which is 100,000. So there are 100,000 ways to perform these tasks. There are 100,000 passwords that can be made using this idea. All right, so that's the first question. Okay, the second question, all right, says how many passwords are possible if only lowercase letters of the alphabet are used? All right, so we know that we have 26 of those, and again, we're not told that we can't repeat any letters. We can do whatever we want. Again, so in this case, and I'm gonna stop writing T1, T2, T3, T4, T5, but pretend it's there. But the idea is that for the first character, right, we have 26, and then times 26. So we have 26 options for each character that we use, right? So in the end, we end up with 26 to the 5th, which is equal to, very big number. So we have 11,881,376. Right, so that's how many passwords you can use if you could only use the lowercase letters of the alphabet. Okay, let's keep going. So now, number 3. How many passwords are possible if there are no restrictions? So no restrictions mean that you have available to you all the lowercase letters and all the 10 numbers, right? So hopefully we can all see that that means that we have now 36 options for characters that we can use, right? So for each task, T1, T2, T3, T4, T5, you have 36 options, right? So in the end, you have 36 ways to do that, times 36, 5 times, right? 36, 36, 36 again. So in the end, you end up with 36 to the 5th power, which is, hopefully you expect that to be a bigger number than in number 2. So you get 60,466,176 passwords that can be made if you do not put any restrictions on the letters or on the numbers, right? So on WebAssign, when you take the quiz, not on WebAssign, on Blackboard, when you take the quiz, definitely make sure that you enter the number. Avoid using commas. I don't know if Blackboard takes that or not, but maybe just put in the numbers without the commas and then put in the entire number. So don't put 36 to the 5th. Just put the actual number, like 6,466,176. So enter the whole number, and the question will tell you enter the whole number. So please do that. Okay, so we've answered 1, 2, 3. Now let's answer number 4. So I'm gonna go ahead and erase some of this stuff over here. And if you look at number 4, it says how many passwords are possible if the characters must alternate between letters and numbers. So that's a little bit tricky, because we know we have 5 characters. We're alternating. So does that mean that we start with a letter and then number, letter, number, and so on? Or do we start with the other way around, right? So you can either start with a letter and go that way, or you can start with a number and then go that way. So we have to account for both possibilities here. So what I mean by that is, all right, so number 4. All right, so let's say I'll just put, so T1, T2, T3, T4, T5, and I'll put them above here, and I'll do 2 ways, right? So first way, and then I'll put the second way here. Right, so the first way, let's say we start with letters first. Let's say the first character is a letter, so we get 26 option. Then the next character is a number, then we get 10, right? Then 26, then 10, then 26, because we're alternating here between letters and numbers. Okay, so that's one way of doing that, right? Multiply these numbers. So what you get when you do that is you get 1,757,600. Okay, then the second way is maybe we start with a number now, right? Then we do a letter, then a number, then a letter, then finally a number again. So when you do it that way, you get 676,000. And hopefully it makes sense why this number should be smaller than the previous one. So you want to account for both possibilities, whether we start with a letter or a number. So what you do in the end is you add these two numbers together, right? So you want to do the first option plus the second option, and what you get in the end is this number. So 2,433,600. Right, so that's how many passwords are possible if you decide to alternate between letters and numbers. You have to add both possibilities. Okay, so that takes care of number 10 on WebAssign. Let's go to the next problem that's relevant to what we might see on the quiz. Is this, and this one should be much shorter. So let's erase. All right, so here it is. So this is number 12 from WebAssign, and I took this one exactly, at least with my numbers. An opinion poll is to be conducted among cable TV viewers. 8 multiple choice questions each with 2 possible answers will be asked. And how many different ways can a viewer complete the poll if exactly one response is given to each question? So in other words, every question must be answered. Right, so you're not allowed to just choose, let's say, 7 out of the 8 questions. You have to answer every question. You have to give one answer, and there is a possibility for 2 answers. So maybe this is like a true or false, yes or no question. Doesn't matter. You have 2 options in this case. All right, so now again, we have to do this whole business of figuring out what is our task. What are the number of ways to do this, right? So task. All right, well, our task here are the 8 questions. Right, so if you had 10 multiple choice questions, you'd have 10 tasks. Right, so the questions are the tasks, and now the number of ways. Well, the number of ways here are the 2 possible options, right? So 2 possible answers right here. Those would be our number of ways to perform these tasks. So then what you would say is, all right, so each question, so for example, I guess T1, T2, T3, T4, T5, T6, and I'm running out of space, T7, and then T8. Okay, and then the number of ways to answer these 8 questions, the number of ways to perform these tasks is always 2, right? Because we're not told that some questions have 2 possible answers and some questions have a different number of possible answers, right? Each question has 2 possible answers, so we'll have 2 possibilities for every single task, every question. So in the end, you end up with 2 to the power of 8. But what you want to enter in WebAssign is the number 256, right? So that answers the question. So there are 256 different ways a viewer can complete the poll. And that is it. That is all we have for section 6.3.